Now here, consider 3 different maths books, 4 different physics books and 5 different chemistry books. So in this question, 3 different maths books, 4 different physics books and 5 different chemistry books are there. Now in first question, what we have to do, in how many ways exactly one book of each subject can be selected. So here you have to select one book of each subject and all 3 books of maths are different, our 4 books of physics are different and all 5 books of chemistry are different. So in this first question we have to select exactly one book of each subject. So how we will select? See, it's a basic question. If you are selecting exactly one book of each subject, this is a basic problem. Okay, so in how many ways you can select? So out of 3 books of maths, all 3 are different, so you can select exactly one book in 3C1 ways. Okay, and out of 4 different books of physics, you can select one book in 4C1 ways, and out of 5 different books of chemistry, you can select exactly one book in 5C1 ways. So total number of ways will be 3C1 into 4C1 into 5C1. So in our basic problems that we already have discussed in basic permutation and combination, you can see if you have to select one boy and one girl out of 4 boys and 5 girls. So you have to select exactly one boy and one girl out of 4 boys and 5 girls. Okay, so in how many ways you can select? So 4C1 into 5C1, or you can use the multiplication principle, 4 into 5. And I also told you one thing there, if you have to select only one student out of 4 boys and 5 girls, so total number of ways will be 4 plus 5, that will be 9. Okay, so you can see you have to select exactly one book of each subject. So total number of ways will be 3C1, 4C1, 5C1, and instead of using this combination, you can also use the multiplication principle that I have told you in the basic problems. So you can use multiplication principle, 3 into 4 into 5. Okay, or you can use the combination concept NCR, 3C1, 4C1 into 5C1. Okay, now the second question is, in how many ways at least one book of each subject can be selected? So this is the basic problem, means if you are studying about at least and at most concept, so don't forget the basic problems. That's why I have told you this basic problem. Okay, now you have to select at least one book of each subject. Now there are 3 different books of maths. So out of 3 different books of maths, how you can select at least one book? How you can select at least one book? You can select one book, you can select 2 books, you can select 3 books. So total number of ways will be what? 3C1 plus 3C2 plus 3C3. And we can use the formula NC1 plus NC2 plus NC3 that I have already discussed before. NC1 plus NC2 dash 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 up to NCN, it will be 2 to the power n. Okay, it will be 2 to the power n. So out of 3 different books, if you have to select at least one books, then total number of ways will be 3C1 plus 3C2 plus 3C3, and we can write 2 to the power 3 minus 1. We can use this formula that we have discussed in binomial theorem. Okay, so here if you have to select at least one book of each subject, so for mathematics, for 3 different books, you can use 2 to the power 3 minus 1, and again for 4 different physics books. So how you will select? At least one book means you have to select at least one book of each subject. So how many books of physics you can select? You can select 1, you can select 2, so 4C1 or 4C2 or 4C3 or 4C, 4. So out of 4 books, you can select 1, 2, 3 or 4. So it will be 2 to the power 4 minus 1. Okay. Again, we can write into 2 to the power 4 minus 1. Now for chemistry, there are 5 different books of chemistry. So how you can select at least one book out of 5 different books of chemistry? 5C1, you will select 1, or 2, 5C2, 5C3, 5C4, 5C5. So here it will be 2 to the power 5 minus 1. So total number of ways will be 2 to the power 5 minus 1. So the total number of ways through which one can select at least one book of each subject, that will be 2 to the power 3 minus 1 into 2 to the power 4 minus 1 into 2 to the power 5 minus 1. This we have done using binomial theorem concept, and once again I will repeat this problem with the concept that I have told you yesterday. In last class, what I told you, out of 3 different books of maths, how you will select at least one? So if you will pick up first book of maths, then there will be 2 ways. One for selection and other for rejection. So for first book of maths, you have 2 ways. One, you will select the book or you will reject the book. You have the option. Why? Because you have to select at least one. No need to select all the books. So with first book, how many options will be there? 2. One for selection, other for rejection. Again, for second book, how many options will be there? Again, 2 options. One for selection, one for rejection. Okay. So 1 plus 1 into 1 plus 1. Again, for third book of math, you have again 2 options. One for selection and other for rejection. So total number of ways will be 1 plus 1 into 1 plus 1 into 1 plus 1. Now, here you can see with these all 3 options that I have wrote here, 1 for rejection in each case. So here one way will be that through which you can reject all the books. Okay. Here one way is there through which you can reject all the books, and we have to reduce that way. Okay. So we will do minus 1 here. Why? Because in each section, one way is for selection and other is for rejection. So 1 plus 1 for first book, 1 plus 1, 1 for selection, 1 for rejection. Second book, 1 for selection, 1 for rejection. Third book, 1 for selection, 1 for rejection. And you have to do minus 1 because we will reduce the option through which we can reject all the books. Okay. Why? Because we have to select at least one book. So we will subtract the way through which we can reject all the books. That's why I am putting minus 1 here. Okay. So you can also think in this manner that for each book of math, there will be 2 options. One for selection, one for rejection. So it will be 2 to the power 3 minus 1. Again, the same concept we can apply for 4 different physics books. If you will pick first physics book, you have 2 options. Again, one rejection, one selection. One through which you can reject the book, and with one option you can select the book. So for first book, 2 options are there. 1 plus 1. Again, for second book, you have 2 options. One for selection, one for rejection. 1 plus 1. Again, for third book, you have 1 for selection, 1 for rejection. And for fourth, again, we have 2 options. 1 for selection and 1 for rejection. Now, what you will do? We will subtract 1 from this total option. Why we will subtract? That I have told you here. You have to select at least one book, and with one way you can reject all the books. So you have to subtract that way. Again, in 4 physics books, we can reject all the books. So one way will be there through which you can reject all the books, and you have to subtract minus 1. Okay, you have to reduce that way through which you are rejecting all the books. because you have to select at least one book of physics. Now for maths, no, for chemistry. For chemistry again, for each book we have two options, one for selection, one for rejection. So the case of chemistry that you can understand easily, first book, one for selection, one for rejection. Second book, again select, reject. For third book, again select, reject. Fourth, again select, reject. And for last fifth book, again select, reject. And we will subtract 1 because through one way we can reject all the books, and we have to reduce that way, okay, so that we can get the required number of ways. So total number of ways will be 2 to the power 3 minus 1, 2 to the power 4 minus 1, and 2 to the power 5 minus 1. Both concept you can use either binomial theorem, or you can use this select reject concept that I have discussed in last lecture. Okay, now in third question, in how many ways at least one book of each subject can be selected? At least one book. Here I am writing at least one book can be selected. So here you have to select at least one book. That may be of chemistry, that may be of physics, that may be of mathematics. And all three maths books are different. All four physics books are different, and all 5 chemistry books are different. You have to select at least one book, okay? So there is no any condition for selecting that maths book, that physics book, and that chemistry book. You can select any one, but you have to select at least, okay? So again, if we will go through binomial theorem, then we will have 4 plus 3 7 plus 5 12 books. So we have 12 books. Out of 12 books you have to select at least one. So how you will select? The ways will be 12C1 plus 12C2 plus 12C3 and 12C12. So it will be NC1 plus NC2 plus NC3 up to NCN. That will be 2 to the power n minus 1. You will write 2 to the power n minus 1 here. That already I kept here. Okay. So 12C1 to 12C12, it will be 2 to the power 12 minus 1. So you can get the total number of ways with the help of binomial theorem. Now, if we will go through the at least and at most concept, so again we have 12 books, 4 plus 3 7 plus 5 12, and again with each book we have two ways, either select or reject. So if you have to select at least one book, there is no any foundation that you have to select exactly one book of maths, exactly one book of physics, exactly one book of maths, or at least one book of physics, at least one book of chemistry, at least one book of maths. So you can select any one book. So you can reject all the books of maths, all the books of chemistry, then you have to select at least one physics. If you will reject all the books of chemistry, all the book of mathematics, you have to select at least one physics. In the same way, if you will reject all physics and all chemistry books, you have to select at least one math. If you will reject all physics, all chemistry books, then you have to select at least one chemistry. So there is no any foundation with individual books. Okay. So all 12 books are different for us. So if you will select any one book out of 12, you have two ways, reject and select. Again, for each of 12 book, you have two ways, select, reject, select, reject, select, reject. So you can also think in that manner. So total number of ways will be 1 plus 1, 1 plus 1, 1 plus 1 12 times. That is 1 plus 1 to the power 12. And out of these all ways, one way will be there through which you can reject all the books. Okay, one way will be there through which you can reject all the books, and you have to reduce that way, so you will subtract 1 from all the ways. Okay, so total number of ways will be 1 plus 1. For each book, 2 options are there, one to select and other to reject. So 1 plus 1, 1 plus 1, 1 plus 1 we will write 12 times and subtract 1, because we have one option through which we can reject all the books, and we have to remove that option, so we will subtract 1 from total ways. So you can think in two manner. One, you can think with binomial, and other select and reject concept that we have discussed in last lecture. Okay, so these are the number of ways through which you can understand this at least and at most problem. So now we will start next question. Consider 3 identical coins, 3 identical 1 rupee coin, 4 identical 5 rupee coins, 5 identical 10 rupees coins, 10 rupee coins, 3 different coins. Now 3 different coins are 1 rupee coin, 1 2 rupee coin and 1 20 rupee coins. In how many ways one can select at least one coin? Means you have to find the total number of ways through which you can select at least one coin out of this all. In the second question, we have to select at least one coin, means we have to select at least one coin, but a 5 rupee coin is always selected. Means this is the condition that you have to select at least one 5 rupee coin. Okay. And now in third question, you have to select again at least one coin, and a 2 rupee coin is always selected, because only 1 2 rupee coin we have in the question. Okay. So how many coins are there? 3 identical 1 rupees, 4 identical 5 rupees, 5 identical 10 rupees and 3 different coins, 1 rupee, 2 rupee and 20 rupee. 3, 5, 8, 4, 12 and 3, 15. So total 15 coins are there. So you have to select at least one coin. So how we will start? Out of 3 identical 1 rupee coin. So we have 3 identical 1 rupee coin. How we will select? I will select one coin and I have 2 options. One select and other is reject. Okay. So for first 1 rupee coin, we have 2 conditions, one for select and one for reject. Okay. But here all 3 coins are identical. So all 3 coins are identical. So how we will proceed? First thing, you will select one coin. Secondly, you will select 2 coin. And third, you will select 3 coins. And fourth, you will select no coin. Okay? Because in our previous question, what was the condition? We had 3 maths books, and the maths books was different, and physics books and chemistry books. All the books of same subject were different, and here all the coins of 1 rupee are alike, are same. So how we will proceed? Out of 3 1 rupee identical coin, the total number of ways will be 1 for selecting 1 coin. Again for selecting 2 coin we have 1 way, because both are same. Okay, both are same. And for selecting 3 coin, again we have only 1 way, because again all the coins are identical. Now if I will select no coin of 1 rupee, then again another 1 way. Okay, to reject all the coins, because it is not necessary that I have to select a coin, a 1 rupee coin. I can reject. Okay, because I have to select at least one coin, and that one coin may be of 1 rupee, 5 rupee, 10 rupee, 20 rupee, 2 rupee, any one of them. Okay, so in this 3 coin we have 4 conditions. One for selecting 1 coin, again another one is for selecting 2 coin, and another one is for selecting 3 coins, and one condition is for rejecting all the coins. So total number of ways will be 3 plus 1. And with 4 identical 5 rupee coin, again the same condition will be there. Out of this 4 identical 5 rupee coin, there will be 4 plus 1 ways. How 4 plus 1 ways? Means you can select 1 coin one way. You will select 2 coin again one way. For 3 coin again one way. For 4 coin again one way, because all are identical. And for rejecting all the coins again one way. So there will be 4 plus 1 ways for 4 identical 5 rupee coins. Now for 4 identical 5 rupee coin. Now for 5 identical 10 rupee coins. Again 5 plus 1 conditions will be there. How? 1 for 1 coin, again 1 for 2 coin, 1 for 3 coin, 1 for 4 coin, and 1 for 5 coins. And one way is to reject all the coins. So there will be total 5 plus 1 ways. And now 3 different coins, 1 rupee, 2 rupee and 20 rupee. 1 coin of 1 rupee, 1 coin of 2 rupee and 1 coin of 20 rupee. Again for each of these coins, we will have 2 conditions. 1 to select and 1 to reject. So for this 1 rupee coin, 1 plus 1. For again this 2 rupee coin, 1 plus 1, and for 20 rupee coin 1 plus 1. 1 to select and other one is to reject. Now we will subtract 1, because I already told you in the last problem that there is a way through which you can reject all the coins, and we have to subtract that way, because here you have to select at least 1 coin. That's why we will subtract 1, because this is the way through which we can reject all the coins. Okay? So now, total number of ways will be 3 plus 1, 4 plus 1, 5 plus 1. And for these 3 different things, you can formulate. I have told you the formula. So for these 3 different things, you can formulate 1 plus 1, 1 plus 1, 1 plus 1. Means for each of the 3 cases, we have 2 ways. Okay, so we can combine these 3. 2 to the power 3 and minus 1. Okay, so these are the total number of ways through which you can select at least 1 coin, and that may be any coin. Here at least 1 coin you have to select, and a 5 rupee coin is always selected. So what will happen? You have to select at least 1 5 rupee coin. Means you have to select at least 1 coin, but a 5 rupee coin must be there. Okay, you have to keep in mind. So what will be the condition with 1 rupee coin? Here 1 rupee coin I already have taken here. So here you can write 100 rupee coin. Okay, 1 rupee coin is already here, so you can write 100 rupee coin. Okay. So at least 1 coin, if a 5 rupee coin is always selected. So with 3 identical 1 rupee coin, total ways will be 3 plus 1, same. And for 4 identical 5 rupee coin, here 4 plus 1 conditions are there, and this 1 condition shows that we have rejected all the coins. But in this condition, we will not reject all 5 rupee coin, because we have to select at least 1 5 rupee coin. So here we will subtract this rejection case. So number of ways will be 4. Okay, so at least condition will be added with 5 rupee coin, then you will subtract 1 from these cases. Why? Because we will subtract the way through which we have rejected all the 5 rupee coin. And again, if instead of 5 rupee coin, a 1 rupee or 10 rupee coin is there, so we will subtract 1 from the corresponding case. Why? Because we will subtract the way through which we have rejected all the coins. Okay. Now, with 5 identical 10 rupee coin, again there is no any conditions. For 10 rupee coin is written here, so we can reject the coin of 10 rupee also. So total number of ways will be 5 plus 1. 1 is for rejection. And now for these 3 different coins, again one select, reject, select, reject, select, reject. Okay, so if a condition is mentioned in the question that you have to select at least one coin of any of the kind, either 1 rupee, either 5 rupee, either 10 rupee, 100 rupee, 2 rupee and 20 rupee. So you have to subtract one from the corresponding condition. Why? Because you will remove the way through which you have rejected all the coins. Okay, so you can understand with this problem. Now, in this condition, again the same type of problem is there. At least one coin you have to select. One can select at least one coin if a 2 rupee coin is always selected. Again, the same question is there. Instead of this 5 rupee coin, we have to select 2 rupee coin. Means only one 2 rupee coin is there. So we have to include a 2 rupee coin. Always it must be included. So the condition will be for this 1 rupee coin, 3 plus 1 because we can reject. Again for 5 rupee coin, 4 plus 1. And for 5 identical 10 rupee coin, it is 5 plus 1. And for 100 rupee coin, it will be 1 plus 1. And for 2 rupee coin, we will subtract 1 from this condition. Why we will subtract 1? We are rejecting the way through which we have rejected 2 rupee coin. Okay, so we will subtract 1 from this condition, so it will be 1 only because we have only one 2 rupee coin. Okay, so you will subtract 1 from which case? In which you have to include that case. You have to always include that case, so we will subtract 1. That is, we will remove the way through which we have rejected the way for selecting 2 rupee coin. Okay, now, so in the next case, 20 rupee coin, we can reject. So select plus reject. So these are the conditions through which you can select a particular coin or you can reject. All the conditions are mentioned. So one thing you have to remember, means straightforward problems are there that you can do easily. You can use the formula. But if some constraints are mentioned in the question, here constraints are, you have to select a 5 rupee coin, means you have to select at least one 5 rupee coin. Here the constraint is you have to select a 2 rupee coin. So if constraint is mentioned in the question, so you have to fulfill that constraint and then you have to move forward. Okay, so always remember in the problems of permutation and combination. Okay, now we can write 3 plus 1, 4 plus 1, 5 plus 1 and 1 plus 1 to the power 2, because here you have to select a 2 rupee coin, so one way will be there. So these are the number of ways through which you can solve this problem. And now we will move ahead towards the number problem. Now in this problem, consider this number 75600. Find the total number of divisors of n. You have to find all the divisors of this number n. Number n means 75600. And in this second part, you have to find all proper divisor. So first of all, I will clear the meaning of proper divisor. Proper divisor means the number itself and 1 should not be taken. Means in proper divisors, the number itself and 1 will be rejected. Okay, so proper divisors of any numbers. If we will consider a number 6, so number of divisors of 6, 1, 2, 3 and 6. So how many proper divisors are there? 2 and 3, because number itself and 1 are not the proper divisor of any number. Okay, number itself and 1 are not the proper divisor of any number. So proper divisor will be 2 and 3, and total number of divisors of 6 will be 1, 2, 3 and 6. Okay, so now you can understand the meaning of proper divisor. Okay. And again in third question, find the total number of even divisors. Even divisors means you have to consider at least once 2. Means number must be multiple of 2. That divisor must be multiple of 2, you can think. Okay, you can say the number must be multiple of 2. And total number of odd divisors means all multiple of 2 will be rejected. Means you have to reject all the 2's. Totally you have to reject all the 2. Because if you will consider 2, then the number will be even. So if you have to find odd divisors, means you have to remove all the 2. Okay. So now we will start from very first question. Total number of divisors of n. First of all, we will factorize this number 75600. 75600. Okay. 2 75600. How many factors are there? So total factors are 42335271. 423352 and 71. Okay. If you will go through the LCM, you will find all the factors. Okay. So 2 to the power 4, 3 to the power 3, 5 to the power 2 and 7 to the power 1. You can compare this question totally with at least and at most condition. Here 4 2's are there, 3 3's are there and 2 5 are there and 1 7 is there. So you can compare 2 with apple. Suppose this 2 is apple. 4 apples are there. This 3 with orange. 3 oranges are there. 5 with grapes. 2 grapes are there. And 7 with watermelon. 1 watermelon is there. Okay. All 4 apples are alike. All 3 oranges are alike. All 2 grapes are alike. And this 1 watermelon. Okay. So total divisors means what? You have to select at least 1 fruit. 2 is apple, 3 is orange, 5 is grape and 7 is watermelon. So out of these fruits, how many fruits are there? 4, 3, 7, 2, 9, 1, 10. You have to select at least 1 fruit. This is the meaning of these divisors. If you will select divisors, what it means? You have to select at least 1 fruit. Out of these, 4 are alike, means 4 2's are there, 4 apples are there. In how many ways you can select at least 1 apple? No. At least 1 apple, no. You have to select at least 1 fruit. So with apple, how many cases will be there? 4 plus 1. How 4 plus 1? Total number of divisors are there. So you can select 2. You can select 2 times 2, that is 4. You can select 3 times 2, that is 8. You can select 4 times 2, that is 16. And you can reject 2 because you can select any other number. Okay. So total number of ways will be 4 plus 1. Out of 4 apples, you have to select 1, 2, 3, 4 and no apple. Now with 3 oranges, 3, 3. Again we will have how many ways? 3 plus 1. In the divisors of this number, 1 3 may be there, 2 3 may be there, 3 3 may be there, no 3 may be there. Okay. So with 3, how many conditions are there? 3 plus 1 and you can compare with that orange problem. So out of 3 oranges, how you can select? 1, 2, 3 and no orange. All 3 oranges are identical. So number of ways will be 3 plus 1. And with 2 grapes means 2 5. If you are considering the divisors of this number, you can select 1 5, 2 5, no 5. No 5 means any other number you will select. So with 2 grapes, you have to select 1 grape, 2 grape, no grape. So conditions will be 2 plus 1. And for 1 watermelon, you can select or reject. Again 2 conditions are there. 1 watermelon means 1 7. So in the divisors of this number, 7 may be there and may not be there. So with 7, how many conditions are there? 1 plus 1. And we have to select at least 1 fruit. Okay. Totally I am comparing this problem with the fruits problem that I have discussed in previous lecture. Okay, previous lecture I already have discussed fruit problems. So now -1 will be there because you are comparing it with fruits problem. And now switch on the number. So 1 is the divisor of every number. Every natural number, 1 is the divisor. So you have to consider that one also. So total number of ways will be, you have to put +1 here. You have to add 1. Why? Because 1 will divide each and every number. So total number of divisors will be 4 plus 1, 3 plus 1, 2 plus 1, 1 plus 1, -1 plus 1, gone, and these are the number of ways. Now, proper divisors of n. So, I already have told you that in proper divisor, we will not consider the number itself and 1. So, what we will do, out of this total divisors, 4 plus 1, 3 plus 1, 2 plus 1, 1 plus 1. We have to reject two divisors, that is a number itself and 1. So, just subtract 2. You will get the proper divisor. Because I already have told you what is the proper divisor. You have to reject the number itself and 1. Now, even divisors. Even divisors means you have to select at least one apple. That I already have told you in the fruit problem, that if you have to select at least one apple, then subtract 1 from all the cases of apple. Because with apple, rejection case will not be there. You can select 1 apple, 2 apple, 3 apple, 4 apple. No apple case will not be there. At least one apple should always be selected. So, what it means, compare this problem. If you have to find even divisors, at least 1, 2 must be there. At least one apple must be there. So, you have to subtract 1 from the cases of 2. Because we will reject the case through which we will reject all the 2's. Because we have to select at least 1, 2. We will find the even divisors with 2 only. If 2 is there, then divisors will be even. Otherwise, no guarantee. So, the conditions will be 4 plus 1. So, +1 will not be there. It will be 4 into 3 plus 1 into 2 plus 1, 1 plus 1. Okay? And no need to do -1 because already we are including at least 2. Okay? So here also think one, you have to think once that at least 1, 2 is always selected. It means we are not selecting 1. Here 1 is the divisor, but here at least 2 will be the divisor. Always remember. And for odd divisors, we have to reject all the apples. We have to reject all the 2's. If you will select at least 1, 2, then it will be an even number. Okay? So now total number of ways will be 3 plus 1, 2 plus 1, 1 plus 1. Except 2, we can select all. Okay? 3, 5, 7, orange, grapes, watermelon. And again -1 because we can reject all the numbers. So you have to remove that way if we are comparing with fruits problem. And add 1 because 1 is also the divisor and not a even divisor. Okay. So finally answer will be 3 plus 1, 2 plus 1 and 1 plus 1. So in this manner you can apply the concept of at least and at most in numbers problem also. Okay. So now we will discuss next problem in next lecture. Thank you.